Welcome to the Insightful Professor. Today we discuss how to handle an exception that has been thrown within a Java program. And we're going to introduce something called the try-catch statement. Let's recap what we talked about in our previous video. We introduced the concept of an exception, and we said that an exception is effectively a signal to the application that some kind of error or warning, in general some kind of unexpected condition, has occurred while the program was executed. We also gave an example of a program in which an exception was thrown, but no attempt was made by that program to deal with that exception. The consequence was that the program terminated rather abruptly. Sometimes when it terminates, the message that you get from the system is a bit confusing, kind of a bit cryptic. So what we're going to look at in this video is how to approach handling an exception, that is, responding to that signaled event. And we will address a couple possible considerations as to how we can deal with this. One would be allow the program to continue execution. That is, we recognize that the signal has been sent to us, we receive it, and we respond in some way. We take some kind of action, and after we take whatever action we determine to be appropriate, we then allow the program to continue execution from that point forward. So that's a possibility. Another possible way to address dealing with an exception is to terminate the program, but do this in a more controlled manner. Recall that with an unhandled exception, with the example that we presented in the previous video, the program just abruptly came to an end, and the message that came out might have been a little bit confusing, a little difficult to understand, because it was generated by the system and not really intended for a casual user of the program. So when we intercept the exception, we can put out our own custom message to kind of politely inform the user of whatever problem had been encountered and tell them perhaps that we're unable to continue, and then gracefully terminate the program. In this way, the program is terminated in a more controlled manner, and the user perhaps doesn't sense the same degree of frustration. So the aim of error handling techniques is really to pass information about whatever that error is from the point at which it occurred within the program to some other point within the program where we're better prepared to deal with that situation, where there's enough information that we can make an informed decision as to perhaps whether we should continue execution or whether we should terminate the program. So exception handling entails basically a type of cooperation between the point within the code where the error is detected and the point within the program where we deal with it. Some kind of communication has to be established between these two sections or points or areas within the program. Now, the way Java and the way many other object-oriented programming languages work is there are exception classes that are predefined, or programmers can design their own exception classes. Remember that an exception is really an object. It's an instance of a class. So there are a set of exception classes that are defined within the Java API, and it's through these classes or through objects instantiated from these classes that we are able to pass information from the point of detection to the point at which we're going to deal with that exception. Remember, exceptions are said to be thrown, so the point at which we deal with it is the point at which we catch the exception. So an exception that isn't handled, just a reminder of what we saw in the previous program, is kind of informally referred to as an unhandled exception. And the default response in such a situation where an unhandled exception arises is for the program to kind of abruptly terminate, and you get a system-generated message, which may or may not be meaningful to you. The structure that we'll use to deal with a thrown exception is called the try-catch statement. And what happens is we have two blocks, two sections within the statement. One is referred to as the try block, and it's the try block where we execute the code that potentially can cause an exception to be thrown. Then, should an exception be thrown, we have associated with the try block something called a catch block. And it's the catch block that responds to the thrown exception. These two blocks are connected together, forming this complete try-catch structure. So in the try block, we execute code that potentially can cause an exception to be thrown. Should an exception be thrown, the catch block has the code that is going to deal with it. Remember that when we talked about the call stack, the try block could effectively be invoking a method that is far distant from the point at which the try-catch construct is situated within our program. So the point is that we could be executing code, say, off in the distance somewhere, and that code signals an exception. Control returns back to our try-catch structure, and the catch block that we've associated with the try, which invoked the method, will then fire or execute and attempt to respond to the situation. So a try block could have several associated catch blocks. That is, when we execute a block of code within the try section, it's possible that more than one type of problem could arise. Perhaps with one statement that we execute that causes one particular exception to occur, or potentially causes one exception to occur. But if that's successful, we go on and execute another instruction, also within that same try block, and this next instruction might potentially cause a different exception to occur. When we code a catch block, the catch block is going to identify by name the exception that the code within the catch block is intended to deal with. So if there are different potential problems that could arise by executing code within a try block, we may very well have multiple catch blocks, where one catch block addresses one particular problem, another catch block addresses a different problem, and so on. So each catch block is referred to as an exception handler because they're prepared to deal with specifically handling some particular exception. Each catch clause handles a particular kind of exception indicated by what we call the exception parameter, where we've identified the name of the exception or the name of the exception type that this particular catch block is prepared to deal with. So when statements in the try block are executed, if no exception is thrown, then none of the exception handlers fire. We just skip right over that, and we continue execution at the statement that immediately follows the entire try-catch statement or try-catch structure. That would be considered, say, the normal execution flow. But if an exception is thrown at any point during execution of the code within a try block, which again may be some far distant code because the instruction we're executing within the try block says go execute this method, and the point is that at any point where an exception is thrown during code that is executing from within the try block, control will then be immediately transferred to that catch structure, and it looks for the appropriate exception handler based upon the name of the exception that was thrown and the name of the exception that is going to be dealt with within that particular catch block. It's also possible that we failed to catch or failed to code a catch block for the exact or precise exception that was thrown, in which case that would also be an unhandled exception. And we'll give some examples of all of this in just a bit as we look at some Java code to kind of cement these ideas together. So let's look at this concept a little more carefully. In our try-catch structure, we have these two distinct regions that we're calling the try block and the catch block. So the try block will include several statements that we might execute, might include a single statement, but in any event, any one of these statements could result in an exception being thrown. But remember, it's also possible that all of these statements execute successfully without any exception being thrown. So the catch block is there kind of as a precaution. Should any of the statements within a try block throw an exception, the catch block may be prepared to deal with that exact exception. So this is kind of optional code in terms of execution. It's kind of like an if-then statement. If a condition is true, the code that follows the test for that condition will execute. But if the condition is false, no matter how much code is immediately following the test of the condition, what happens is that code won't execute. So we either execute it or we don't. So there's code there that may or may not execute. That's exactly the idea of how the catch block works. In any event, there's the possibility that if we go through sequentially and do our instructions, say from top to bottom in the try block, that we could be successful and skip everything in the catch block. Or we get thrown into the catch block should an exception arise, and we execute the instructions within the catch block sequentially. And then what happens is we execute whatever statement follows the try-catch structure. That's kind of one scenario. Remember, we talked about two scenarios. One where we handle it and then continue executing. This is what would happen. But if we handle it and terminate the program, then presumably the last instruction within the catch block would say exit the program. So let's see what happens. If all statements in the try block execute without an exception being thrown, execution skips over all of the instructions within the catch block and resumes at the instruction coded immediately after the try catch. And here's the scenario. So all this stuff in the catch block, it's as though it didn't exist because everything within the try block was successful, so we jumped right down here. That would be the next sequential instruction. Same concept as with conditional logic implemented with an if-then type of statement. If executing any statement within a try block causes an exception to be thrown, and here we've highlighted one in red to say perhaps this is the one that triggers the exception being thrown, then any remaining statements within the try block will not have an opportunity to execute. We jump out immediately into the catch block. We exit the try block with no option to return to the code within the try block, and execute the code within the associated catch block, provided that we have one that satisfies the condition that's been thrown. So that means there could be additional instructions within a try block that are not given the opportunity to execute because we immediately abort the processing of the try block. So again, we emphasize that control is not going to be returned to the try block. We basically did a go-to, kind of a one-way ticket we bought to exit the try block. We're not going back. When a try-catch statement is executed, the statements in the try block are executed. The statements tell what to do when everything goes smoothly. That is, presumably we'll execute all of the statements in the try block if no problems arise. But if an exception is thrown at any point within the execution of instructions within the try block, then this is the exceptional condition that occurs, and we abruptly terminate control of the try block and kind of deviate from the normal execution flow. Instead of being a straight sequential execution, we then jump out into the catch block. So we kind of broke that normal execution flow. So control is going to be transferred into the catch block. But remember, we can have more than one catch block. So should a catch block exist for, say, problem 1, and a second catch block exist for problem 2, then whichever problem was detected, problem 1 or problem 2, only the code in the appropriately labeled catch block will execute. The other code is ignored. So here's what it might look like. Remember we talked about our example in the first program in the previous video where we did not handle the exception. What we're doing now is within the try block, we are performing an operation which may or may not cause an exception to occur. Remember, the exception that we experienced in the previous program was divide by 0. So should the denominator here happen to be 0, we will again be attempting to divide by 0. But now we're executing that division within the confines of the try block. So if the exception is thrown, control would be thrown down here into the catch block. And remember, the name of the exception is actually called arithmetic exception. That's the name that we're prepared to handle here. So this is our exception argument E is the name of the actual exception object, and the name of the exception class is called arithmetic exception, which would be the exception if we attempted to divide by 0. So we have a match. So if we attempt to divide by 0, control goes down here to the catch block, and this very catch block that we've coded is the one that can deal with that divide by 0, the arithmetic exception. And all we're simply doing is saying we caught the exception, and then we continue execution. But if it was some other exception that occurred here, it was not an arithmetic exception, then the only one that we've attempted to address here is called arithmetic exception. So if it was a different exception name, it's considered unhandled, and we get the default behavior, which is to terminate the program with an error. Let's take a look at the complete code for this program in a file called 02.java and show you the exact behavior. We've described it, but let's see it in action. Okay, so here we are in my IDE with the source code for 02.java. I have a whole bunch of comments at the beginning of the source file. I'm jumping right down to where the actual code is located. So it's called 02. We declare the numerator as an integer, give it a value of 10. The denominator, integer as well, give it a value of 0, and then we attempt to do the division. And of course we know what's going to happen. We're going to try to divide by 0, and that's going to cause the problem to occur. So let's execute this code and watch how the system responds. What happened here was we did the division, but the division failed because it was a divide by 0 exception. The name of the exception is arithmetic exception. And what happens is control is thrown into my corresponding catch block here. This message is then printed out, and we see it displayed down here, caught the arithmetic exception. Notice that that is the end of the catch block. In fact, it's the end of the entire try-catch statement. Given the fact that this is sequential execution and we completed successfully the execution of the code in the catch block, we fall out of the catch block and then execute the next instruction that appears sequentially after the try-catch statement, which does a print of the message that says this text will now be printed. And that explains what happens here. But notice the program ran to successful completion. So in this scenario, what happened was we caught the exception, dealt with it, didn't do much to deal with it, we simply displayed a message, but then we allowed the program to continue execution. We'll show you another scenario a little bit later where we'll terminate the program. But let's go back here and change the situation a little bit with this particular program. Let's say we divide 10 by 10. So that means this division will be successful and will not cause an exception to be thrown. We're no longer dividing by 0. So we've taken the provision here, the caution that should the exception be thrown, we're prepared to deal with it in this catch block. But in this case, no exception will be thrown. So let's watch the behavior of the program as we run it this time. Now what happens is this produces the result. 10 divided by 10 is 1, and systemout.println will display the result. It displays 1. So we executed all of the code within the try block successfully. No exceptions were thrown. Therefore, what happened was we skipped over all of the code within the catch block and then executed whatever code sequentially followed the try-catch statement, which again prints out this message down here. This text will now be printed. And that gives us a quick example of how the try-catch block is intended to work, where we allow the program to continue execution after intercepting and, say, dealing with whatever that exception is. There's a concept that we also want to understand here called exception propagation. If an exception is not caught and handled where it occurs, then what happens is it becomes the responsibility of the routine that invoked the routine that caused the exception to occur to deal with that exception. Hopefully that makes sense. So the point is, if you execute a block of code and an exception is thrown and you deal with it, it's just as we've described thus far. But if you execute a block of code, which is, say, some distant method being invoked, and that method throws an exception but doesn't deal with it, then the exception comes back to us at the point where we invoked that method, and it becomes our responsibility to deal with it. That's called exception propagation. If an exception is not caught and handled where it occurs, say within some method that we may have invoked, control is going to be returned to the point at which that method was invoked, and it becomes the responsibility of the code at that location to deal with the exception. So it's possible to design an application such that the exception is caught and handled outside the point at which it's detected, at this outer level. Okay, that's where we're waiting for the exception to come back to us. So if it's not caught there, then it goes back to the point that invoked that particular location of code, until finally it gets to some point that is going to deal with the exception, or we get all the way back to the initial location from the operating system or the runtime environment that says, let's get this whole thing underway. So again, it has to be dealt with in some way, and if it's not, ultimately the user will get the result of an unhandled exception, get a nasty message. So the catch block is kind of like defining a method. What happens is we define what is being passed into the catch block as some kind of a parameter. The parameter's type is whatever the exception class is, like arithmetic exception, for example. And E, in this example here, would be the actual instance of that exception class. That's an object of the exception class. That's the exception object. It's that object that carries or conveys the message or the information about what the error is back to the catch block, so the catch block can deal with it. So the catch block is technically a separate piece of code, distinct from the code that caused the exception to be, say, thrown or be detected. And the catch block simply is the code that's going to deal with the situation. So the catch block parameter allows for two things to happen. It specifies the type of exception to be thrown. It could be something like arithmetic exception. It could be file not found exception, or it could be exception as we're showing here, starting with an uppercase E. That's kind of the mother of all exceptions. This is the base exception type from which many of the other exceptions that we'll see as we work with Java kind of descend. So they're derived from this particular exception class. So the catch block parameter also provides a name for the thrown object. That would be this E that we saw up here, on which the catch block can then execute. And we'll show you how we can actually utilize that to invoke a special method called getMessage. Okay, so here we have a try catch block that says we're going to try to access an array element and then divide that value by some other value. So there are two possible things that could go wrong here. We're trying to access an element within the array, and the element within the array might not exist. There might not be an element with a subscript or index of 1. Additionally, when we get that value, if that's successful, we're trying to do division, and it's possible that this variable called denominator could contain a value of 0, so we could get another exception where we attempt to divide by 0. So a couple things could go wrong with executing this instruction. So we deal with each situation separately. What we have is, in the first case, we're saying we've got this thing called array index out of bounds exception. That's where this subscript or index might not be valid. There might not be an element with an index or subscript of 1. If that's the case, then this is the problem that occurs. That's the exception that's thrown, and we deal with it by printing out this message. Again, that's all we do. We don't terminate the program in this case. The second exception that we deal with is our familiar arithmetic exception. This is triggered by a divide by 0 type of event, which is what could happen over here. So the second situation could arise where we fetched the value from the array successfully, then we attempt to divide that by the denominator, which happens to have a value of 0, so that could cause the second exception to occur. There was no need to place these in any particular order. I could have said catch arithmetic exception first, and then secondly catch array index out of bounds exception. When an exception is thrown, the system will kind of go through the list of catch blocks in order and say, well, let me check this one. Is that the problem that occurred? No, it isn't. Let me go on. Is this the problem that occurred? Yes, it is. Let me handle it here. Let me execute this code. So it goes through that list in order that they physically occur, not necessarily in any other order. So let's take a look at some of this code in action. I've got a couple more examples I'll throw at you, and we'll try to piece this together and see how it makes sense. So here's a variation on the program we were just looking at. This one is called 03. What 03 does is it declares an array and then attempts to do that exact instruction that we had discussed in our presentation a moment ago. We're trying to divide element subscript 1 by the denominator. Notice the denominator has a value of 0 assigned back at line 29. So if our assumption was that the only thing that could go wrong is we try to access an element in the array and there's no such element, that is, the subscript or the index is out of range or out of bounds, we then put an exception to deal with that. Maybe that's all we thought that was going to happen, or all that we thought that could happen, so we deal with that situation. But notice there is clearly a set of values within the array, so there's not a problem with element subscript 1, because there are multiple elements within that. So clearly we have element subscript 0, element subscript 1, element subscript 2, and so forth. So this element does indeed exist, which means that this exception is not going to be thrown. But what we failed to take into account in this particular example was we're also doing division, and it's possible we could be dividing by 0. So let's watch what happens when we fire up this code. We get our familiar arithmetic exception divide by 0 problem. Here's what happened. We attempted to do this operation, which is requiring a couple of things to happen. We attempt to fetch element subscript 1 from the array. Turns out that's successful. So then we take that value and attempt to divide it by whatever's in denominator. But as we saw, denominator contains a value of 0, so an exception is thrown. The only exception handler we have is prepared to deal with the array index being out of range or out of bounds. The exception that was thrown is called arithmetic exception. It's an unhandled exception. So again, what happens is it's back at line 33, we see the offending instruction, but even though we had an exception handler, it was not the appropriate exception handler for the exception that was thrown. So this brings us to the modified version of code that we examined a couple moments ago, 04, where we include a second exception handler. Let's fire this guy up and watch what happens. Circumstances are the same, where we have denominator being 0. There are several elements within the array, so array subscript of 1 will be resolved, but when we attempt to divide by denominator, that's a divide by 0. We have a separate catch block or exception handler to deal with that situation. Let's see what happens. Now, program terminates gracefully. It terminates gracefully because this is the exception that was thrown, and we said to respond to that by printing out this message. Then we allowed the program to continue after that, and what we see is it then executed this. Just to emphasize the point I had made earlier, the order here is not important. Let's take these two exception handlers and switch their order. So now I'm catching the arithmetic exception first, and then I attempt to catch the array index out of bounds. Let's fire this up and see what happens now that I've changed the order. Same exact behavior as before, so the order didn't matter, okay? So we've got some flexibility there. But what is critical from this example is that we can catch more than one exception and deal with the different exceptions we catch in different ways. Take a look at one more program, and then we'll discuss a couple more fine points about the try-catch. In this program, what I have is, again, the array that has multiple elements. I have this integer variable denominator initialized to 0, and again, I'm attempting to do my division. But what I want to show you is the exceptions that I'm handling. I'm handling an array-related exception, the array out of bounds, or index out of bounds, something called array store exception, some other exception that could arise when dealing with arrays. And then I'm handling this thing called exception. But I'm not specifically handling the arithmetic exception where we could get the divide by 0 type of issue. What this exception down here is dealing with, by the way, is this is the general exception. All of the other exceptions, like array index out of bounds exception, arithmetic exception, array store exception, they're all derived from exception. So these are specific or specialized cases, and the exception, as we see here, is spelled with the uppercase E, is what we call the base class. That's the very general. This will cover anything. If I didn't have these exception handlers here, this covers everything. But we don't necessarily want to do that because we don't know what the problem is if we use this general exception. It could be any one of the ones that I've attempted to catch, or any of these many others that exist that I've made no direct effort to catch. I will catch everything, so I don't really have the detailed information to inform the user as to what the problem is, or perhaps to try to remedy the situation. So we are going to put this general exception last. So let's go ahead and look at this execution here. So it says it caught any other type of exception. Where did that come up? That's down here. The general exception handler printed out this message. So the problem, as we know from looking at this code, is it was a divide by 0, an arithmetic exception. Clearly, this is not the arithmetic exception. This is not the arithmetic exception. Even though arithmetic exception was not explicitly identified, it was considered to be handled because that was a specific case of a general exception, and the general exception will catch everything. So if we were to switch things around here, let's show you what happens. If I attempt to take this general exception and say, let me list that first, all of a sudden I've got problems. Notice I've got the little red squiggly marks here. The compiler is not too thrilled about this. In fact, I haven't compiled it yet. It's the IDE that's responding. But if I attempt to compile it, I'm actually going to get compile errors. And what happens is, if I look at the explanation of this, what it's telling me is this is an unreachable catch block. If you think about the behavior of what we talked about previously as to how the catch blocks are examined, we said it didn't make any difference what order they were listed in. Well, that's when we were using all of these kind of specialized cases. But when we use the general case, no matter what the exception is, this is going to be where we go. This block will execute. Because this is like, I'll catch anything. So if you catch anything, this code down here could never execute, because this array index out of bounds exception would be caught up here. This block could never execute, because this array store exception would be caught up here. So this code could never possibly be reached. It could never be executed. That's what the IDE is telling us. That's what the compiler tells us when we compile it and get the error. So the general exception, the most general case, has to be listed last if you're going to include these specific or specialized cases as well as the general case. So the order is important when you include the general case. So now notice as I look at the code, I have no errors indicated by the IDE. And this is the code we originally worked with. Now let's go back to the handout for a moment and we'll revisit this code with another modification. Okay, here we are. We say there are more exception classes than just exception. That's what we've seen already, and that's what was illustrated in our last example. Exception is the general class. We could get by with using that, but we wouldn't know exactly what the problem is, so that we couldn't handle it specifically within our exception handler. This is why we use a multitude of exceptions, and then if we're going to catch everything that could happen beyond those that we've specifically identified, then we use the exception as denoted here, the general exception handler. So we could create our own exceptions, but that's beyond the scope of what we want to talk about in this current video. But that's another possibility, and they could be derived from this as well. Now, all predefined exception classes have the following properties. There's a constructor. That's what brings it into existence. So when an exception is thrown, a new instance of that exception class is brought into existence. That's done by invoking the constructor. That constructor takes a single argument of type string. This is where we can pass a message from the point at which the exception is thrown or detected back to the point at which the exception is handled or dealt with. And then we can examine that message to see what happened. How do we examine that message? Good question. Well, conveniently, we have this method called getMessage that's available to us. That's also part of this exception class and part of all exceptions that are derived from that. So all the exceptions can have this string that explains what went wrong, and we can then examine that message, that string, in our exception handler code by invoking getMessage. This is actually quite neat. Here's how it's done. What happens is in our catch block, remember we give a name to that exception. So we're going to call it, in our case here, we're just going to call the object E. E is then used to qualify calls to getMessage. It's kind of like when we were dealing with scanner objects. We create the scanner object, say to read from the keyboard or read from the file, and then we use that object name dot next int or next line or some method to extract data from the input source. Here the object happens to be E, the name of our exception object, and getMessage is the method we're invoking. And again, we use the dot operator to qualify the call. So we take this and it returns to us the string that was created when the exception constructor was invoked. Then we simply take that and display it to the screen. One additional thing about this particular piece of code is that this guy says we're going to terminate the program. All examples that we've discussed so far have said we've intercepted or dealt with the exception and then allow the program to continue execution. But should we intercept it and it be such that we cannot realistically or practically continue execution, we have to terminate the program. But again, this is done in a controlled fashion rather than just abruptly terminate it and send a cryptic message to the user. So we terminate the program by invoking system.exit and give a return code. 0 usually signifies everything was good, so normally we would give something like a negative number as a return code to send back the message or the indicator that things didn't go so well. So let's put this code into play. We'll go back into our system, take a look at this, and what we're going to do is we're going to go into our exception handler, and we're going to change this a little bit. Instead of catching the exception and simply putting out this message down here, we're going to remove that block of code. And we're going to deal with the general exception in a little bit different situation. We're using that object parameter, E, to qualify a call to the getMessage method. And we're going to take the message, the string that's returned, display it, and then terminate the program. When we terminate the program, we kind of come to a screeching halt, and we don't execute the code that sequentially follows the try-catch block. So let's fire this up and see what happens. We execute the code, and it says divide by 0. Where'd that come from? That was the message that was placed into the object when the exception constructor was invoked. and we're simply extracting that message and displaying it. So that came about from this line here. That's how it appeared on the screen. But notice that this line was not given the opportunity to execute because we simply terminated the program here. Came to a screeching halt. We said it's impossible to continue, so we're just going to put the whole execution to an end, and that's it. So anyway, that's an illustration of the second approach. Pretty interesting stuff. So what have we talked about in this section? We covered quite a bit of ground. We introduced the syntax of the try statement, technically the try-catch statement, and we explained the notion of the try block and explained the notion of the catch block or blocks. Remember, we could have more than one. It's within the try block that we take code that we're going to execute that potentially could throw an exception. It might not, but it could possibly throw an exception. In the associated catch block or catch blocks, we have code that will deal with different exceptions that could be thrown. So we catch an exception based upon the name of the exception, and that's the exception that the corresponding code is prepared to deal with. Should we have an exception thrown for which there's no corresponding catch block, it's considered an unhandled exception. We discussed this notion of exception propagation, and then we also demonstrated how we could use multiple catch blocks, precisely what we were talking about here. And then finally, we talked about how we could examine the actual error message that was contained within the exception object and convey that to the user if necessary. So the code that we provided illustrated a number of important ideas and concepts for using the try-catch statement. These examples can be found on our associated website, www.timhartley.com. Feel free to grab those and try these things out for yourself. And if you have any comments, please feel free to offer them in the comments section below. And if you enjoyed the video, give us a thumbs up. Also, consider subscribing to the channel so you're made aware of when we post future videos. And once again, thanks for watching.